question about waves here. It's asking to, well, we've got a diagram with two waves overlapping each other, and it asks for one quantity that is the same for two waves. So if we're looking at quantity, we're looking at things like the wavelength, the frequency, the amplitude, and we're looking for one that's the same. So if we look at our two waves, we've got the sort of taller one and the shorter one here, but the thing that obviously strikes straight away that's the same is this kind of distance from here to here, or is going to be the same as that. Or in a similar way, we could say that distance is going to be the same as that. And each way you look at it, you could also look at that one, but we're all talking about the wavelength. So one thing that is the same there is the wavelength. You could also say the frequency, but I think it's simpler just looking at the diagram to say that the wavelength is the same there. And then one quantity that is different. When we look at the things that are different, we're looking at this height of the wave here from there to there. And that, of course, is going to be the amplitude. Now, lots of people, it's not relevant to this question, but lots of people assume, for instance, if we clear all of this off, lots of people, if they were looking at this question, would assume that the amplitude is that. Don't be that person, don't make that mistake. Amplitude is from the middle point to the furthest displacement, the furthest distance from that middle point. So that's the amplitude of that wave, and that's the amplitude of that wave. And so the amplitude, so what are we saying? The thing that's the same, wavelength. The thing that's different, amplitude. Okay. So in diagram 1, there are two transverse waves. Which of the following types of wave is not transverse? So it's asking which ones of these are the other one, which is longitudinal. So gamma rays are in the same family as light and X-rays and all of those. Gamma rays, X-rays, radio waves, and visible light, they are all transverse waves. So the one that's not, the one which is made up of compressions and rare refractions, that is your sound wave. And then last part of this question, we've got the waves coming towards this little gap, and as you can see, as they go through the gap, they spread out. We get this diffraction. Quite often in higher questions, they'll ask you about how that relates to how much these spread out. And basically, if that gap there is the same as the wavelength, that's when you get the biggest diffraction, most of this curving. But again, we're not going to worry about that today. They're not asking us about that. They're actually asking us about the speed of the wave. And it's actually asking for the wave equation, because we've got one wave every second, 8 waves pass through. So what does that mean? That means the frequency is equal to 8, and the unit for frequency is hertz, 8 hertz. And we've got a wavelength of 0.015 meters, so pretty small, okay? But as long as you can remember that the one wave equation you need to know for waves, the velocity of the wave is the frequency times by the wavelength, and we use that funny little Greek letter lambda for the wavelength. So we have got a frequency of 8 multiplied by the wavelength, which is 0.015. You pop that into your calculator and you come out with an answer of 0.12 meters. Is it meters? Yes, this is in meters, so we are good, we are in meters. So that's how you'd work that one out.